Classification of insects. The insects have invaded almost all habitats. They occur commonly everywhere and differ widely in their form, structure, and behavior in relation to the mode of life they have adapted. They are so abundant in their total number of species that they represent about 80% of the animal kingdom. Till now, about 7,15,000 species of living insects and 12,000 species of fossil insects have been recorded, and yet a large number of species to be discovered in future. Due to these facts, the insect taxonomy is a very exhaustive and ever-growing branch of entomology. Foundation of insect taxonomy was first laid down by Linnaeus in 1758 to 68. He classified the entire group of insects into 9 orders: Coleoptera, Orthoptera, Hemiptera, Lepidoptera, Neuroptera, Hymenoptera, Diptera, Thysanoptera, and Diptera. With advancement in our knowledge, number of orders have been reorganized and added from time to time. Fabricius Elateral et al. In 1831, Breuer in 1885, Heinrich in 1908. Some other scientists, other workers made several modifications and additions in the original system of classification of Linnaeus. Class Insecta into 2 subclasses, Epterygota and Pterygota, consisting 16 orders. With the discovery of fossil insects, the classification received new dimensions after Heinrich in 1908. The modern scheme of classification was initially proposed by Eames in 1925 to 51 and later on modified by Richards and Davis in 1957 and adopted universally, as it is justifying phylogenetic interrelationship among various groups of insects and their evolutionary trends. So, modern scheme of insect classification, subclasses. Since the time of Brunner in 1885, the class Insecta is divided into 2 subclasses, Epterygota and Pterygota. Epterygota are the primarily wingless insects bearing pregenital abdominal appendages. Primarily wingless insects bearing pregenital abdominal appendages, and their development passes through a little or without metamorphosis. They characteristically possesses monocondylic mandibles. Pterygota are the winged or secondarily apterous insects without pregenital abdominal appendages, and their development passes through metamorphosis. They possess dicondylic mandibles. The subclass Pterygota is divided into 2 divisions, Exopterygota or hemimetabola and Endopterygota or holometabola. The Exopterygota represents the insects showing external development of the wings in the form of wing buds, incomplete metamorphosis without a transitional pupal stage, and immature stages resembling the adults in form and structure, which are commonly termed as nymphs. The subclass Pterygota is divided into 2 divisions, Exopterygota or hemimetabola and Endopterygota or holometabola. Okay. The Exopterygota represents the insect showing external development of the wings in the form of wing buds, incomplete metamorphosis without a transitional pupal stage. The subclass Pterygota is divided into 2 divisions, Exopterygota or hemimetabola and Endopterygota or holometabola. The Exopterygota represents the insects showing external development of the wings in the form of wing buds, incomplete metamorphosis without a transitional pupal stage, and the immature stages resembling the adults in form and structure, which are commonly termed as nymphs. The Endopterygota represents the insect showing wing development internally in the form of wing discs. complete metamorphosis with a transitional pupal stage and the immature stages differing from the adults in form and structure, which are often called the larvae. Taxonomic grouping of orders. The Epterygota orders. The subclass Epterygota consists of 4 orders: Thysanura, Diplura, Protura, and Columbola. They are widely diversified from each other, representing heterogeneous assemblies having polyphyletic origin and some abnormal insect characters. So Thysanura, moreover, show their close relationship with the main evolutionary stock of Pterygota. The Pterygote orders. The subclass Pterygota consists of about 25 orders, 16 in Exopterygota and the remaining 9 in Endopterygota division. Sorry, that was my cat. Martineau in 1925 to 1938 distinguished it into 2 groups, infraclasses, Paleoptera and Neoptera. The Paleoptera includes only 2 existing orders, the Epimeroptera and Odonata, which cannot flex their wings over the abdomen. The Neoptera consist of all other pterygote orders which are adapted for wing flexing mechanism. The Neopteran orders of Exopterygota division are divided into 2 groups, the Polyneoptera or orthopteroid and Palaeonoptera or hemipteroid groups, while the orders of Endopterygota form a single group, the Oligoneoptera. So, we just mentioned the insecten stock classified into Epterygota, Paleoptera, Orthopteroidea, Hemipteroidea, Neuropteroidea, and Hymenopteroidea. Insecten stock Epterygota, Paleoptera, Orthopteroidea, Hemipteroidea, Neuropteroidea, Hymenopteroidea, Panaropoidea. So, Epterygota again into Columbola, Protura, Diplura, Thysanura, then Paleoptera, Columbola, Protura, Diplura, Thysanura, Epimeroptera, Odonata, Plecoptera, Embioptera, Orthoptera, Phasmida, Dermaptera, Zoraptera, Grilloblattoidea, Dictyoptera, Isoptera, Hemiptera, Thysanoptera, Socoptera, Anoplura, Malophaga, Coleoptera, Neuroptera, Hymenoptera, Lepidoptera, Trichoptera, Mecoptera, Siphonaptera, Strepsiptera, Diptera. Okay. First one, the Neopteran order. Oh, no, it's not Neoptera. The Polyneoptera. That's a orthopteroid group. Polyneoptera, orthopteroid group. The orders are Plecoptera, Grilloblattoidea, Orthoptera, Phasmida, Dermaptera, Embioptera, Dictyoptera, Isoptera, and Zoraptera. They are commonly characterized by mandibulate mouthparts, Hind wings bearing a large anal lobe, presence of cerci, presence of large number of malpighian tubules, and the ventral nerve cord bearing large number of genitalia. Once again, characters of Polyneoptera. Polyneoptera. That's a orthopteroid group. Polyneoptera, orthopteroid group. Mandibulate mouth parts, hind wings bearing a large anal lobe, presence of cerci, presence of large number of malpighian tubules, and the ventral nerve cord bearing large number of genitalia. Then the Paraneoptera, hemipteroid organ, hemipteroid group. Paraneoptera. It consists of remaining orders of the Exopterygota division: Socoptera, Malophaga, Sipangulata, Hemiptera, and Thysanoptera. They show some common characters such as specialized piercing and sucking or suctorial mouthparts, hind wings without large anal lobe, absence of cerci, extremely condensed ventral nerve cord, fluid sucking, raptorial, suctorial or saprophagous mode of feeding, and fewer number of malpighian tubules. Oligoneoptera, that is a panorpoid complex. It is commonly agreed since the work of Tilliard in 1918 to 35 that the endopterygote orders Oligoneoptera are 9 in number. The 6 orders Neuroptera, Mecoptera, Lepidoptera, Trichoptera, Diptera, and Siphonoptera constitute the panorpoid complex. Remaining 3 orders, Hymenoptera, Coleoptera, and Strepsiptera, do not show marked close interrelationship either with the orders of panorpoid complex or with each other. They are supposed to be evolved independently and do not form a monophyletic group. So schemes of classification, we try to learn about that. Various classification schemes of class Insecta. It's a brief survey. So scheme of classification Linnaeus in 1758. 9 orders based on wing structure and evolution, which are Coleoptera, Hemiptera, Neuroptera, Diptera, Eptera, Orthoptera, Lepidoptera, Hymenoptera, Thysanoptera. Okay. Then Fabricius in 1775, 8 orders based on mouth parts. Eleutheræta, that's a Coleoptera actually. Then Eulonata, that's Orthoptera, Blattidia, Dermaptera, then Sinistata, Epimera, Phryganus, Apterygota, Perlides, Neuroptera, Socoptera, Panorpus, Hymenoptera, Isoptera, Crustacea. Then Agonata, scorpions and crustaceans. Along with that, Unogata, Libellula, Myriapoda, Arachnida. Then Glosata, Lepidoptera, Rhynchonta, Hemiptera, Apiniptera, Cesaloptera. Antillata, Diptera, Anoplura, Malophagra, Arachnida, Crustacea. Then literally Aptera and Alata based on wing and mouth parts. Then Elytroptera, Gymnoptera. That again classified into Thysanura, that is an apterygote, then Parasita, Malophaga, Siphonoptera, Orthoptera, Coleoptera, Dermaptera, Hemiptera. Then the next one, Hymenoptera, that is transferred into Neuroptera, Odonata, Epimerites, Panoreps, Zoopsids, Isoptera, Embioptera, Hymenoptera, like that. Then later, modern schemes of insect classification, Richards and Davis in 1957, Hepterigot, Ectognatha and Endognatha, Thysanura, Diplura, Protura, Columbola. Then Pterygota, Exopterygota, Epimeroptera, Hemimetabola, Odonata, Paleopteran orders, Plecoptera, Grilloblatoidea, Orthoptera, Phasmida, Dermaptera, Embioptera, Dictyoptera, Isoptera, Soraptera. Polyneopteran orders. Then Pterygota, Exopterygota and Hemimetabola actually. Then Epimeroptera, Odonata, Plecoptera, Grilloblatoidea, Orthoptera, Phasmida, Dermaptera, Embioptera, Dictyoptera, Isoptera, Zoraptera. These are actually included under Paleopteran orders and Polyneopteran orders also. Then Paraneopteran orders, that is hemipteroid group, Soacoptera, Malophaga, Sipungulata, Hemiptera, Thysanoptera. Then Endopterygota, Holometabola, Oligoneopteran orders, Phaneropoid complex, Neuroptera, Mecoptera, Lepidoptera, Trichoptera, Diptera, Siphonoptera, Hymenoptera, Coleoptera and Strepsiptera. Thysanura, Diplura, Protura, Columbola, Epimeroptera, Odonata, Plecoptera, Grilloblatoidea, then Orthoptera, Phasmida, Dermaptera, Embioptera, Dictyoptera, Isoptera, Soraptera, Soacoptera, Malophaga, Sipungulata, Hemiptera, Neuroptera, Thysanoptera, Mecoptera, Lepidoptera, Trichoptera, along with that Diptera, Siphonoptera, Hymenoptera, Coleoptera, Strepsiptera, etc. Then extinct insect orders. Paleontological studies revealed some extinct insects, mostly from their well-preserved wings in the fossils of coal, lignite, peats, and amber impregnated with resin of Pennsylvanian or Permian to the lower Carboniferous age. The earliest columbolan has been recorded from the Middle Devonian fossil peat bag of rain in the Scotland, while Paleodictyoptera, Protoroptera, Protodonata, Megasectoptera, and Protoblatoidea are obtained from the fossils of Carboniferous period. There are about 11 extinct insect orders. The classification is mostly based on the wing venation. Most of the insects become extinct before the end of Permian period. They had much primitive morphological features in comparison to their descendants and are widely considered as the early ancestors of several existing orders. The brief synopsis of these orders is given below. Subclass Pterygota, order Monura. They resemble Microcorphila or Archaeognatha in having 10 complete segments with paired stylets in the abdomen but without cerci. They belong to Upper Carboniferous and Lower Permian period. Then subclass Pterygota, order 2, Paleodictyoptera. They were large and stout with the wingspan of 20 cm and some may had even more than 40 cm. The peculiar feature of interest is the prothorax with a pair of lobes attached to the pronotum. They were very large, sclerotized and showed a venation system homologous to wing venation. They had abdomen like Epimeropteran nymphs and multi-segmental cerci about twice the length of abdomen. The female had a long ovipositor while male with claspers with paired edegyes. They were existing during Pennsylvanian and Permian periods. Pterygota, Paleodictyoptera. Then Megasecoptera. They were slender, medium to large in size with long cerci and sucking beak-like mouthparts with falcate or hooded-shaped wings having specialized wing venation. They were recorded from Pennsylvanian fossils, Aspidothorax and Pseudohymen. Then order Diaphanopteroidea. They resemble with Paleodictyoptera and Megasecoptera except that they were able to fold their wings over the body. They are recorded from strata of Pennsylvanian and Permian age. In order 5, Protodonata. They were largest in size with wingspan between 12 to 75 cm. They closely resembled dragonflies and with large eyes, long slender body, strong mandibles and wing venation. They appeared in Pennsylvanian or Triassic period. It is considered that they gave rise to the Odonata during the Pennsylvanian age. Then Proto-Orthoptera. They were the earliest fossil neopterans characterized by coriaceous forewings and with expanded anal lobe bearing hind wings and by mandibulate or shearing mouthparts. Suborder Protoblattoidea resemble with cockroaches. They had archidactylian venation pattern with 7 anal veins on fore and hind wings. They occurred during Pennsylvanian to Permian age. Then order 7, Miomoptera. They were small-sized extinct insects resembling Sochoptera and were bearing mandibulate mouthparts and short cerci. They were existing during early Pennsylvanian to Permian period. Then order 8, Caloneuroidea. They were resembling Isoptera as their fore and hind wings are mostly identical and the mandibulate mouthparts and extremely short cerci. It was Pennsylvanian Permian order. For example, Paleothygramma. Then Proteccoleoptera. The insects were small and were characterized by modification of forewings into elytra and hind wings with longitudinal and transverse folds in an enlarged anal veins, strong legs, short cerci, stout antennae, etc. They were preserved in Permian fossils. They thought to be the ancestors of Dermaptera rather than Coleoptera. Protilectra. Then order 10, Protopleria. These insects were obtained from Permian sediments and closely related to Plecoptera. They had 4 wings longer than the hind ones and related 5 anal veins. Some Protopleria possessed lateral flat lobes on prothorax. The hind legs were stout and larger than others and the cerci were long. Then order 11, Glossolatroidea. It is the only extinct endopterygote neopteran order. The 4 wings become elytra, venation become complex and resemble with Neuroptera. They recovered from Permian to the Jurassic period. Archeglossoptera. Now we are going to enter into epterygote orders with the help of next video. Thank you.